Okay, just the simplest. It's A11 times M11, where M is the 1, 1 minor. Okay? So, let's just define what Mij is. And I'm going to just define it with words because it'd be really hard to totally notate it, okay? And confusing and all kinds of things. Mij is the thing that you're familiar with, is the matrix obtained by deleting row I and column J from the matrix A. And we can denote the matrix A by Aij, okay? And we might even put a subscript on here to indicate the dimension of the matrix. But it's usually implicit. We usually don't have to do that, okay? And it has to be a square matrix. You talk about a determinant. And you can't do the determinant unless the matrix is square. Okay, so A11 times M11 means you multiply this times this, right? Except, well, yeah, I'm going to write it out for the 1, 1 row. So that's going to be minus A12 M12 plus A1 n minus 1. I'll use a comma when it's needed to avoid ambiguity, because if I just wrote 1 n minus 1, you don't know which is the number of rows and which is the number of columns. It wouldn't be clear. Okay? And actually n could be even or odd. So at this point, I shouldn't have written what I did. I'll just write out the last term. Okay, be negative 1 to the n plus 1 times A1n, so that if n is an even number, you're going to end with a negative. Okay? Because n is even, n plus 1 is odd, and an odd power of negative 1 is negative. Okay? And if n is odd, then you end up with a positive. And it's not A1n, it's M1n. Okay? Now the more general definition is also equal to A J1, and again, got 3 terms to write. I'm going to write them in this order. Negative 1 to the J plus 1, then it's M J1 plus negative 1 to the J plus 2, A J2, M J2, okay? Now what's this mean? where are AJ1, AJ2, and I left off AJN. I need a brain implant. Forget stuff like that. Clerical brain implant. Okay? Conceptually, I'm okay. I think. How would I know the difference? Okay. So it makes sense? Okay? So where's AJ1, AJ2, and AJN, and all the other AJIs between? Well, where's A11, A12 up through the A1N that I didn't write down?
Top row.
Okay, so where's AJ1 through AJN?
Bottom row.
No, AN1 through ANN.
Oh. Some other row.
Huh?
Some other row.
Yeah, any old row. It's the jth row. Okay? So here we expanded on the first row. Here we expanded on the jth row, right? And that equals what am I doing here?
The 0?
The what?
I don't know. Wait, vertically.
Huh?
Yeah,
What do you mean?
vertically.
Doing the tomahawk thing, what team does that?
Yeah, I think the word's columns.
Yeah, it's a column.
Okay.
We're doing, which column?
Column I.
Yeah. So this is expanded on column I. And it ends with -1 to the n plus I, a, n, I, m, n, I. Okay? So it says, doesn't matter what row or column you use, you get the same thing. Okay? Which, among other things, makes it really convenient. If you've got a row or column with lots of zeros, you want to expand on that row or column because you're going to get a 0 for that row or column. If you've got n terms, make as many of them 0 as you can. Okay? Alternatively, row reduce your matrix a little bit. If you see a row that is the same as another row or a multiple of another row, well, if you add a multiple of a row to a row, what's that do to the determinant? Well, by the elementary matrices, you're multiplying by the corresponding elementary matrix is going to multiply your determinant by that number. Okay? You multiply. Actually, no. I think I said, and I lost track of what I said, if you multiply a row by a number, you multiply a determinant by that number. But if you add a multiple of a row to another row, it doesn't change it. It doesn't change the determinant. Okay? So if you get a lot of rows, or a lot of zeros in a row or a column, by adding a row or column, the same thing goes with the column, the determinant of a matrix is equal to the determinant of the transpose. And the transpose just switches rows and columns. So what you can say about expanding on the rows of a matrix is the same thing as what you say about expanding on the columns, as far as the determinant is concerned. Okay? Okay. So anyhow, you want to make those connections. There's big booming, buzzing confusion here. There are a lot of connections that can be made. So, yeah, make as many as you can. Okay, so anyhow, there we go. There's your definition. Now there's a little terminology, okay? Mij is the ij minor of the matrix. Okay? And then you have this other thing, Cij. That's called the ij cofactor. So to get the determinant, you just add up all the cofactors that you get for a row or a column. Right? That's just terminology. The pattern's simple. You do a few, as many as necessary, and I don't think either of you is going to need to do a whole lot of them to get the pattern. I think you already understand it pretty well. But I haven't looked at your homework yet. And I don't think I've assigned anything that requires you to know that, but
For clarification.
what we've done, you know.
For clarification, would this notation be accurate?